Hi, my name is Yunting. I'm a student from class Senior 3 Science 2. Today, I'm going to talk about the ionic equilibria question in UEC past year exam. Now, let us begin. I'm going to have a quick explanation about Bronsted-Lowry theory. According to Bronsted-Lowry theory, an acid will tend to donate proton and a base will prefer to accept proton. The key to solve this question is to identify which shaded species gains or releases a proton in the reaction, as this is the definition of base or acid. So, for the first option A, hydrogen sulfate ion react with hydronium ion to form sulfuric acid and water. The shaded species is hydronium ion. In this reaction, we can see that hydronium ion
has lost a hydrogen atom while the other one gained.
Since it donated a proton, hydronium ion acts as an acid, not a base. For the second option B, hydrogen sulfate ion react with nitric acid to form nitrooxonium ion and sulfate ion. The shaded species is hydrogen sulfate ion. In this reaction, we can see that nitric acid has gained a hydrogen atom while the other one loses. Since the shaded species donated a proton, hydrogen sulfate ion acts as an acid, not a base. And for option C, hydrogen carbonate ion react with dihydrogen phosphate ion to form hydrogen phosphate ion and water and carbon dioxide. The shaded species is hydrogen carbonate ion. This reaction is trickier compared to the other options because the product carbonic acid is unstable and will immediately decompose into carbon dioxide and water. We must look at initial proton transfer. First, dihydrogen phosphate ion has a proton to donate, so it acts as an acid and hydrogen carbonate ion accepts that proton. The newly formed of carbonic acid is unstable and will decompose. The following equations are shown in the picture. In this reaction, the shaded species hydrogen carbonate ion accepted a proton from dihydrogen phosphate ion. Therefore, according to the Bronsted-Lowry definition, the shaded species acts as a base. For the last option D, ethanoic acid react with nitric acid to form protonated ethanoic acid and nitrate ion. The shaded species is nitric acid. In this reaction, we can see that nitric acid has lost a hydrogen atom while the other one gained. Since the shaded species donated a proton, it acts as an acid, not a base. As conclusion, 3 of the option A, B, and D act as an acid and only option C acts as a base. Hence, the answer is C. And that is all from me. Thanks for watching.